In this video, we're going to look at examples of how to find images of complex numbers under the action of the complex exponential function. So f of z is equals to e to the power z. So in number one, we want to find the images of Zn equals to 1 plus n pi I over 4, where n are integers between 0 and 9. And then from there, question says, hence find the image of the vertical straight line z equals to y, 1 plus iy. Okay, we're just going to look at that, and then we're going to come back to number 2. So what we have is number 1, z equals 1 n pi I over 4. N runs from 0 to 9. So first of all, we're just going to generate these numbers. So z naught is simply going to be 1. z1 is going to be 1 plus pi I over 4. z2 going to be 1 plus pi I over 2. z3 1 plus 3 pi I over 4. z4 1 plus pi I, etc. The last one, z9 is going to be 1 plus 9 pi I over 4. What we're going to do is we're going to make a sketch, just plotting these complex numbers. So all the complex numbers have a real part of 1. It's just the imaginary part that changes. So all of them are going to be along the line x equal to 1. It's going to be along this vertical line. So z0, z1, z2, z3, z4, z5, z6, z7, z8, and z9. So z0 is 1, z2, z3, z4 is 1 plus pi I, z5, z6, z7, z8 is so n is 8, 1 plus 2 pi I, etc. So those are the complex numbers. Then here we're going to, so here we've got the x and y. So this is our z plane, and then on the right hand side here we're going to have our w plane. So this is going to be u here, and this is going to be v. Now so we know that f of z is e to the power z. So for each of these we simply plug in z here and we get the image. So for the image of z0, we're going to call it w0. So we simply plug in z0 here. z0 is 1. So that means the image of w0 or image of z naught is simply e. So e is just a real number, so we're going to put it there. So that is w naught. Then we're going to go to the image of z1, which is w1. So that one is going to be 1 plus I pi over 4. So we can write this as e times e to the I pi over 4. So now, from our knowledge of the complex, of the exponential representation of complex numbers, this is just going to be a number which is going to be located at distance e from the origin. So it's going to be on the same circle as this number w naught, but the argument is going to be pi on 4. So it's going to be like here. So what we're going to do is we are going to just make a circle here. So this is a circle of radius e, and then w1 is going to be on that circle, but it's going to be at the angle of pi on 4. So w1 is going to be here, where this angle is pi on 4, which is that angle there. Okay, and then it's going to be exactly the same thing for w2, which is the image of z2. z2 is 1 plus I pi on 2. So 1 plus I pi on 2 going to be e times e to the I pi on 2. Again, it's going to be at a radial distance of e from the origin. The argument is pi on 2. So that one is going to be right here on the vertical axis. So it's going to be w2. Then w3 is going to be 1 plus 3I pi on 4. So it's going to be e times e to the 3I pi over 4. So that one is going to be in the second quadrant on the circumference of our circle. It's going to be w3. w4, 1 plus I pi, just 1 plus I pi. So that one is going to be on the real axis. This is e times e to the I pi. E to the I pi is -1. So that one is going to be on the opposite end to w naught. It's w4. If you continue accordingly, so w5 is going to be here, w6, w7, and then w8. So let's just jump to w8. w8 is 1 plus 2 pi I. Okay, yeah, we noted it here. So that's the image of z8, e to the power 1 plus 2 pi I. This is e times e to the 2 pi I. But e to the 2 pi I is just 1. So this is going to be e. So this is going to be the same as w naught. So just to clear this one up, this is cosine 2 pi plus I sine 2 pi. Cosine 2 pi is 1 and sine 2 pi is 0. So we notice that the image of W8 is exactly the same as the image of W0. So that one is going to be located there. So W8, and then similarly W9 is going to be the same as W1. So it's going to be the same as W10. So what's happening here is that we notice that the complex exponential function is going to be periodic. Now, if you look at these two, they are separated by the difference between the two of them is 2 pi I. And the same thing, the difference between Z1 and Z9 is going to be 2 pi I. So what we're noticing here is that the complex exponential function e to the power z is actually 2 pi I periodic. What do we mean by this? We mean that f of z plus 2 pi I is exactly the same as f of z. This is a big departure from the case of the real exponential function, because we know that the real exponential function is not periodic at all. So that sorts out the first question, part A of number 1. So we found out all the images of these numbers. Next thing, what is going to be the image of the vertical straight line z equals to 1 plus iy? Well, from what we've done, we can see that this suggests that this vertical line here, if you transform it or map it using the exponential function, it's going to actually map onto a circle centered at the origin, radius e to the power 1. So even the points this side on the of the line will all map onto the circle, and that's the reason, partly that's the reason why we've got the periodicity, because once you have got a circle, then of course you're going to have periodicity. But we can do this algebraically as well. So part B, the image of e to the 1 plus iy going to be e times e to the iy. Now, so this is just going to have, it's just going to be a point on the circle of radius e, and y is going to be our argument. So the radial distance is always the same. All that's going to happen is as you change y, you change the argument. So if y is pi on 4, then we're here. If y is pi on 2, we're here. If y is 3 pi I on 2, we are there, etc. So that means z equals to 1 plus iy maps onto e cosine y plus I sine y, which is going to be a circle. So that sorts out, that finishes number 1. In number 2, we've got a similar question, find the images of these points. N runs between 0 and 5. Then hence find the image of the straight line z equals to x plus pi. Okay, we recommend that you have a go at this one, and then when you go to our next video, you're going to find the solution of this example number 2. Otherwise, thank you for watching now. Please of course do subscribe. We hope the material is useful to you.